the period is going to be 100. So the period is 180 degrees. So if you divide it by 4, you find that your step on your calculator is going to be 45 degrees. So you start from 0, then 45, 90, 135, 180, 225, 270, 315, then 360. As always, in grade 10, we only sketch these graphs from 0 to what? To 360 degrees. So if you take out your calculator, just to show you how the table comes up to be like that, right? Remember, you go to mode, then number 7 table for me is number 7. Then my function is tan x, so tan, then alpha, then x, close the bracket. G, I'll put 0. So we are starting from 0, then we are ending at 360. Then our step here is 45. For the graph of tan, the step is 45 degrees. Right? So the calculator will give you that table. Right? Now I want you to look carefully at 90. At 90 it says what? Error. That error, it means there is no y value when x is what? 90. So when we sketch the graph, we are going to have what's called an asymptote, which is a straight line, okay, which is approached by the graph, but never touched by the graph. So the graph will never pass x equal to 90. Okay? So between 0 and 90, the first curve is going to be between 0 and 90, but it will never touch 90 degrees. There will be an asymptote. And when you draw the graph of time, you have to indicate this first asymptote. If you carry on going down, you are going to find that at x equal to 270, we are going to have another value of x which gives us error. There is no y value at x equal to 270. So we are going to have a second asymptote. So the graph of tan has got 2 asymptotes. So when you sketch the graph of tan, first thing, you draw your x-axis, your y-axis, and then you draw the asymptotes. Okay? You draw your asymptotes. Then, between 0 and 90, you plot now. When x is 0, y is 0. So that's this point. When x is 45, y is 1, which is that point. Right? Then you join them by drawing a nice curve going up. But that curve should not touch the asymptote at 90 degrees. Are you following that? Also, after 90, we have got 135. So 135, y is minus 1. Then at 180, y is 0. And then at 225, y is 1. Now here you have to draw a full tan curve between 90 and 270. So we start from the bottom, then you go nicely past 135, then 180, then 225, then it goes. But it will not touch the asymptote. You have to use free hand to do that. Right? So we are now at 270. Yeah. After 270, we have 315. So at 315, x is going to be minus 1. Right? Then at x equal to 360, y is going to be 0. So you draw the opposite of this one now. Okay? It has to go down like that. So that's when we draw it in the fourth quadrant between 270 and 360. So in the end, you're supposed to have one full curve and 2 half curves. One in the first quadrant, the other one in the fourth quadrant. Okay? Huh? Then, any other tan graph comes from this one. So we just move it up, or we move it what? Down.
So this is like the mother graph.
The mother for the tan graphs.
What is written inside?
What? It's undefined. Here I indicate that it's undefined. Y is undefined. Here, y is undefined is the same as error on your calculator. There is no what? Y value.
So what is written with the second domain?
The second what?
Domain.
Okay. Now let's come to the properties. The amplitude of a tan graph is undefined. It's not like sine and cos.
Because there's no specific amplitude.
Yes, there's no specific amplitude for the time graph. So the amplitude is what? Undefined. The domain is from 0 to 360, including the 0 and the 360 parts.
Period. Just period.
Okay, period is 180. Period is 180. So every 180 degrees, the time graph repeats itself.
Oh, yeah.
Okay? The period of a time graph is not 360 like sine and cos. It's what? 180. Then the domain is from 0 to 360, but you have to state that x is not 90, because your calculator tells us so. X is undefined at 90. Also at 270, x is undefined. Okay, sorry now. This is supposed to be x is not equal to 270 degrees. This. Okay? So at x, if you write your domain and you don't state that x is not 90 and x is not equal to 270, means your answer will be incorrect. Okay? Then your range, it's y is an element of real numbers because there is no amplitude. So your amplitude is going to be all the values of y from minus infinity up to positive infinity. So when you write the range for the time graph, it's y is an element of real numbers. For any time graph, those properties are applicable to any time graph in this grade. Hello? Are you following that?
Yes.
Okay. So, let's then produce for a question. Okay. If you don't have a question, then let's sketch. Let's do another sketch now. Okay, so let's carry on. Alright. So, what function? When I create my own function. Right, so we are going to sketch the graph of f of x. Okay, let's do one where we are moving the graph up. 2x, sorry, tan x plus 1. So, when I have tan x, alpha x, you do it as I'm doing it, please. Because you already know how to use a calculator. So I expect you to start doing it now. Tan x plus 1.
What starts at 0?
You start at 0. Then you end at 360. Your step is 45. So you get that value. Okay? So when x is 0, y is 1. Right? I'm going to show you how to state it. So you also do it. When x is 0, y is 1, which is there. But before I do that, I'm supposed to draw my two asymptotes. One at what? 90. Before I go anywhere, then another one at 270. Okay?
Wait, so these don't work first.
So, x is 0, y is 1. When x is 45, y is 2. So 2 is here. Okay, let me. Sorry, my. I want to do that. So let's start. Asymptote first. Okay. Then let's plot. So when x is right, then there's the 2 like that. So I'm gonna draw my first curve in the first quadrant. So my first curve is gonna look like that.
And then you continue to the top.
Do not touch the asymptote.
You have to continue to the top.
What do
Every
you
time.
Yes.
Okay.
On the top. Right. And then when x is 90, that's where you've got your asymptote. So when x is 135, right? Y is 0. Okay, so we are here now. We are here. Then when x is 180, then that's 1. 225, that's 2. Okay? So when I sketch it, it will look like this. Start at the bottom, then it goes, then it goes. 300. Okay? Then, when x is 315, you go to your table. Remember, you no longer have to worry now. You just use, so y is 0, and then at 360, that will be 1. Okay? So, we've got 315 here and then 60. So, when you sketch, you start from the bottom, then it goes, passes through 315, then it stops at 360. So you have that. So this is the graph of f of x equal to tan x plus 1. Okay? So if you want to write its properties, if you want to write its properties, amplitude, okay, that's undefined. Right? Period is 180 degrees. Your domain is x is an element of real numbers, but in this case we are starting from 0 degrees up to 360, but x is not equal to 90 and x is not equal to 270. Okay? Then your range is y is an element of real numbers. Okay? So this is what we have.
So I can just
Which part?
put down second y to become the
Remember we said the y values, they start from minus infinity. Yeah, this should guide you when you are drawing. You have to start from the bottom. Okay? Thoughts.
So people are out.
Okay? Then, since this one here, we are starting from x equal to minus 1, we start from here. So we go all the way. Okay, let me use a different color. It will look nice if I use a different color, isn't it? So we go like that.
So
Okay?
you first has to bend this way because it's negative.
No, it starts from here, then it goes all the way. Right?
So the bend that
Does the hotspot give or take at negative at 40 at negative at 1?
yes.
No, it's minus 1.
So it doesn't have to like bend
Okay,
like
wait,
that.
I'm following that. When x is 0, y is minus, it's minus 1.
Then in 45
And x is
45.
y.
Okay, alright. The equation which you use is which equation?
It
X
is
is 1, minus 1.
Huh?
minus 1.
It's the same thing.
2 times minus 1.
It's 2 tan x minus what?
Minus 1.
Minus 1, right? So when x is 0, 2 tan 0 will give you 0.
When x
So 0 minus 1 will give you minus 1.
yes,
So
and
it
then
starts
x
here.
is 45. It's
Yes,
y
it
is
starts
at
there.
1.
It's not 0.
When x is 45,
It's
it's
1.
supposed to be 1. Okay, I see what you mean.
Yes.
No, okay, I see what you mean. So I think I didn't see that. Alright, let's fix that. It's not a major thing. We're gonna fix it.
You're paying attention.
Don't worry. Don't worry, we're gonna fix it. So it shows that you are paying attention. Now, what this means is we need to know what is the x-intercept. Now, to get that x-intercept, you have to put y equal to 0. Okay? We are back to equations now. So 2 tan x minus 1 is equal to f of x, right?
Yes.
So we put 0 there. Then we have got this equation 2 tan x minus 1. So we get 2 tan x equal to 1, and then tan x is equal to what? A half. Then what is shift tan of a half? What is shift tan of a half?
Negative 30. 30, sir.
Don't guess.
I'm serious, it's 30.
No, it's not.
Wait,
You've got to calculate what is shift tan of a half.
wait, it's 30.
26,5.
You hear that? So that 26 now, we have to approximate, so we have got 22,5 somewhere there. So 26, I'm gonna put it there. Okay? So when I draw, I have to go that way. And then go. Okay.
So that matter how close to the line it is.
Yeah, it can be too close, but it mustn't touch the asymptote.
So it doesn't. It can also be far. Can it also be away?
Too far. Okay, you can try your best to make it a little bit closer to the line. That will depend on the scale and all that. Right? Then, when x is 90, obviously we've got our asymptote. Right? Then we have 135, that's minus 3. So minus 3 I'm going to put right at the bottom. Okay? Minus 3 is going to be here. Okay?
Which get that?
Then 180 is going to be minus 1. Minus 1 is right? I'm getting the values there.
No, so the half and there's a ton, the
Because you
ton
got
before.
that
I substitute y equal to 0. F of x is y.
No, so to get 26,5
Yes. What is the value of y here?
26,5
The value of y here.
Zero.
It's 0. So where there is f of x in the equation, you put 0 there, then you solve for x. You see, this is the original equation, right? We want the value of x where y is what? 0. So we put 0 here. Then we get that. It's now a trigonometric what? Equation. We've done trigonometric equation. So how do you solve the x from here? You take the minus 1 to the right, divide both sides by 2, then you take your upturn of a half. Okay? Are you following there?
Yes.
So 180 is minus 1, which is where I am here. Then 225 is 1. 225 is going to be 1, which is there. Right? Then I can just join. So this will be, okay, let me use the same color that I used there. We don't expect, but we need an x-intercept. Now to get the x-intercept,
Must use training.
right? We use the same angle. Now, do you agree with me that from 0 to 90, that's the first quadrant?
Yes.
Do you agree with me then?
Yes, sir.
Yes.
Can you pay attention, please? Pay attention. From 90 to 180, that's the second what? Second quadrant. From 180 to 27, that's what? Third quadrant. Now, do you agree with me that the x-intercept is going to be in the third quadrant, right?
Yes.
By observation. So if I give you 26, you say it was 26, what here?
5, 6.
26,557. If I give you 26,57 and I ask you to determine an angle in the third quadrant, how would you get it?
In the third quadrant.
Yeah, I say this is 26,57. Find an angle in the third quadrant, which gives you the same ratio as a half.
When I say 10.
You don't even go as far as
I'll say, this is cos.
Let's not talk about cost.
Sign.
No.
No, guys.
Don't talk about sign. Don't talk about sign and cos. I'm saying we know that 26,57 is in the first quadrant. We want to get an angle which is in the third quadrant. That is an angle between 180 and 270. But we are given 26,57. How can we use 26,57 to get an angle in the third quadrant?
You minus it from the total. So you minus it from the total of
Wait. Don't rush to answer the question. Think first.
So you said it repeats every 90 degrees, right?
This is 26,57. It's in the first quadrant. Tan is positive in the what? first quadrant. Tan is positive in the third quadrant. Don't forget your cast diagram.
And it's also positive in the first one.
Yes. So 26,57. Tan 26,57 gives you a specific ratio, which is equivalent to tan of an angle in the third quadrant. But to get the one in the third quadrant, you have to use the 26,57. So how can you use 26,57 to determine an angle in the third quadrant? That's my question.
We don't know.
So,
Don't rush to say you don't know. That's why I say think.
your question is very deep.
We want an angle in the third quadrant, which is related to 26,57. But we only know 26,57. So how can we use 26,57 to get the angle in the third quadrant? That's my question.
We say 180 minus that 26,57.
So is 180 minus 26,57 going to give you an angle in the third quadrant?
Oh, third quadrant.
Yeah.
So, no, wait a second.
You're almost there. You've got the answer.
170 minus.
Go back to the first answer that you said 180 minus what? 26,57.
What's in that
But you
one?
get an angle in the
Add,
third
so you
quadrant.
add, sir.
You add what and what?
So you add 180 plus 26.
Thank you.
So, but that's how I started. As soon as I said you have to minus
Okay, so what that means is
I
this
know.
point here, if we add 180 to it, we are going to get to a point here which is going to be in the what? Third quadrant. So that will be 180 plus 26,57, which will give us 206,57. So if I approximate that, maybe I'll say it's somewhere there. So I'll just go straight there and there.
So can you write it?
Okay.
Wait, so you
Yeah,
need
it's there.
these angles on the x-axis, on the x-axis. You need these angles, the 2-point compass.
You need to know where is the graph going to cross the x-axis. Where is it going to cross the x-axis?
So we must do.
Yes,
We have to have that.
you have to know.
Say, can you write it?
So this is 26,57 and this is 206,57. Right? Let's get on. Let's get on. We are almost there. Then 315 is going to be minus 3. Okay, so 315 and then we have got minus 1. So 315 is going to be minus 3, which is, okay, I'm so sorry. My point is somewhere there. Then minus 1 is there. So when I sketch it, fortunately, I don't need an x-intercept anymore. Okay, now check this. If you add this one in and that one, you get one full curve, which looks like this one. Okay?
Oh, what did the thing repeat itself?
Easy, baby, easy.
Okay, so between 0 and 360, you have 2 tan curves.
This is actually very cool.
What? Are you following? Between 0 and 360, you have what? 2 tan curves. But the one of them is a full tan curve, the others are like half and half. So if you add this one to that, you get one full one. Okay? So let's write the properties and then we can go after that. Right? So your amplitude is undefined.
So when you get up to say it's undefined,
Yes. If the question asks you for the amplitude,
why did it ask you?
then you don't have to answer the question. This is 180. Then domain.
You're only getting it now?
Now, can I have your attention? With regard to the properties of a tan graph, They are the same for any tan graph in grade 10. These four properties. Take note which properties I'm talking about. Amplitude, period, domain, range.
Range, bro.
They are the
Never
same.
change.
Yes, they don't change.